and I will introduce our research modeling two-way selection preference for person-job fit. With the rapid development of internet technology, online recruitment has become a prevalent service, which matches qualified candidates with suitable jobs. Due to the massive growth of candidates and recruiters, it is critical to design effective algorithms to establish high-quality connections between job seekers and employers through the recommendation mechanism. Such a task is called person-job fit. In the literature, a variety of studies has been conducted for person-job fit, such as reciprocal recommendation, job recommendation, and job-oriented skill measurement. Since the information of job and candidate is usually organized and described in textual documents, many text-based person-job fit works has been proposed in recent years. They learn matching functions by modeling the textual semantics. This method can also be regarded as content-based reciprocal recommendation approaches. However, existing studies either model the one-way selection process or overall matching relation. Since the recruitment process involves two sides, candidates and employers, it naturally reflects the two-way selection preference from both perspectives. In order to achieve a person-job fit, both sides involved should meet the expectation of each other. On online platforms, it is common to see unilateral satisfaction cases. For example, job seekers apply for a job, but is refused by the employer. Actually, two-way selection is a common phenomenon in nature and society, and it is important to consider such a bilateral matching process in person-job fit. To improve the person-job fit, we explicitly model the two-way selection preference from the dual perspective of candidates and employers. We develop our solution based on a graph representation learning approach. The core idea is to incorporate two different nodes for each candidate, and it is the same with the job. One captures its own preference to select the job, and the other reflects the preference from the employer. In this way, we can model both successful matching and failed matching via a unified interaction graph. Based on such graph, we propose a novel dual perspective graph representation learning approach for modeling two-way selection intentions. There are two major technical contributions in our approach. First, we learn both active and passive representations via hybrid preference propagation, capturing the node characteristics to actively select and to be passive selected for person-job interaction. Secondly, we design an effective optimization algorithm for learning node representations, which involves a quadruple-based loss and a dual perspective constructive learning loss. The overall architecture is here. There are four parts, and then I will introduce each part in detail. First is the dual perspective interaction graph. In this graph, each candidate and job is represented with two nodes. These two kinds of nodes aim to capture the preference to actively select others or be passive selected by others. The edges are constructed by the different interactions. For example, as shown in this figure, the candidate is represented with two circular nodes, and the job are represented with square nodes. In this case, the candidate apply for the job 2 and be reached out from job 3. Both interactions are failed, and then the candidate reached an agreement with job 1. Edges are constructed as the figure shows. The candidate active node is connected with passive node of job 1 and job 2. The candidate passive node is connected with job 1 and job 3. In addition, the two nodes of the same user are also connected. Second is the initialization of the node representations. The node representation is fused with two parts, the preference ID embedding and the text embedding. The two parts is connected as the initial node representations. It should be noted that for the two nodes of the same user, this part is different, while this part is different. but this part is the same at the beginning. For the propagating, we'll adopt a lightweight propagation mechanism to update the node representations. It is worth noting that the differences are inherent in edge type rather than node type, so the preference propagation of all nodes can be defined uniformly. The final representation for each node is the average of each layer. For prediction, we can compute the two intention scores with the inner product of the corresponding node. These two scores is between candidate I and job K. And finally, we integrate the two intention scores to predict the matching score as follows. For optimization, we adopt a ranking-based approach to optimize the entire model. First, we introduced a quadruple-based loss function. Given a matched pair Ci and Jk, we construct a quadruple like this. By sampling a non-matched candidate and a non-matched job. Then we extend the widely used BPR loss as follows. This is the score of the positive pairs, and this is the score of two negative pairs. And this is a sigmoid function. Besides, we design a dual perspective constructive learning optimization function. Specifically, we treated the two representations of the same user as the positive pairs, and that between users as the negative pairs. As this picture shows, these are from the same candidate, and these are from different candidates. Then we adopt the info NCE loss to maximize the agreement of positive pairs and minimize that of negative pairs. Combining that from two sides, the finally objective function is given as this. We evaluate our model on three large real-world data sets provided by a popular online recruitment platform. The data set was constructed from 106 days real online logs and contained two kinds of behavior. The overall statistics are shown here. We compared our methods with three categories of 10 baseline models: the collaborative filtering-based model, the content-based model, and the hybrid model. Here is partial results of the main experiment, and others can be found in the paper. We employ four widely used metrics for comparison, and do the evaluation for two ranking tasks. The left four columns is ranking jobs for candidates, and the right four columns is ranking candidates for employers. In this dataset, our model is 7% better than the best baseline. Besides, we do ablation studies, and the results indicate that all three components, the dual perspective interaction graph, the quadruple-based loss, and the contrastive loss are all useful to improve the performance. The parameter tuning results is shown below. We examine the robustness of our model with 3K hyperparameters, the layer of GNN, the temperature of the contrastive loss, and the weight of contrastive loss. Finally, we sample a job candidate pair for case study. We calculate two preference scores here. These two scores means that the candidate may like the job, while the employer doesn't satisfy him. In this situation, it is not suitable to recommend this candidate to the job. But for some other models, such as RecSys or BPJFN, the results may be the opposite. For that's the model in our paper. And here we present some future work. For future work, we may consider adding some more additional features for better performance, such as salary ranges and chronological sequential behavior histories. Besides, since the two sides in this scenario can be regarded as two groups of users, we will explore how to balance these two stakeholders. That's all, and thank you for listening.
Thank you. So if you have any questions, please write them on Slido. There's one question so far. Sort of linking to what you spoke about in your last slide. So given that there are several stakeholder groups in a job recruitment process, would your approach be able to account for several more stakeholders than only the two ones that you currently have?
Do you mean the different stakeholder, how to balance it?
So some, let's say, the job seeker, the company, and teams at the company, for instance. So other stakeholders that are involved in the recruitment.
In this paper, we didn't consider such so many different stakeholders, and we just focused on the two sides of this seminar.
Okay, thank you. Are there any more questions? Okay then, thank you again.
Oh, thank you.